I got here on the bench this Teddy Varimixer. It kind of somewhat works. For one, you can hear it, the whisk is contacting the bowl, and I don't like it. It shouldn't happen. Otherwise, this seems to work. There's just a couple of problems with this unit. Something's wrong with this cord. It sometimes totally cuts power to the unit, and second of all, when it's powered, it can still open up, which it shouldn't do. It should only open up here in this position, but so it doesn't lock. Alright, this needs fixing. This has been already written off, so I can butcher it. On the other side, which I'm trying to show you with one hand, this is where the switch goes, and it's already missing here. That's how I got it. I see a little steel ball there, spring loaded, doing something. Maybe that was a fourth. Something that broke off there from there, something that's sticking out like this. I don't know. I'm gonna explore this unit and see why it's not locking or what's wrong with it. Let me just put the camera here, and this way I can show you. If I remove this whisk and the bowl so nothing is noisy. Good. That there is something rattling inside this switch. There. So it's losing the marbles inside, or whatever is inside. It's not working. So I'm gonna get to it. There are really no exposed screws anywhere on the machine. Anywhere. There's nothing anywhere. So I'm gonna start prying and see what happens. I started digging down here. This is the machine upside down, and apparently I have a model W5A, and when I remove these 4 bolts here that hold this panel, I actually came across the place that actually produces motion. There was this plate here, just mounted with 2 screws, super simple, and on this plate this little transformer was sitting. I just leave it there because that's gonna help me weigh this thing down so it doesn't spring back on me. And how motion looks like is fairly straightforward. Look at the spring. There's a rod around which springs are, and it extends and it looks like this, and some springs are spaced apart with washers that spin and move. The whole thing moves. I mean, moves this way, whatever, you get the idea there, and they're loosely spaced apart there. So, and locking is produced here in the middle there. This tab and that tab, those cylindrical tabs, are supposed to catch and clear these little notches here in the metal, but they don't. They kind of they're almost there, but they just don't. So the length of this rod needs to be adjusted so it actually drops in place, and since it's threaded way down there, it shouldn't be a big deal to adjust it, and there, it shouldn't be a big deal to adjust it there, and make it locking again. When I operate this release function, what happens is a push rod is operated in the middle of this. So, and now I need both of my hands. Oops, other way around with this switch. Just a sec. There, so that's the motion that releases this rod from its locked position when the mixer needs to be tilted up. So that's super simple. I just experiment with these shapes until they work. I'll keep you posted. With the biggie wrench and the adjustable pliers, I made one full turn on this rod, so now it actually locks in position. There's the release button there, it opens, and there it drops into place. Release again, and drops into place, clicks into place nicely. So of course I took out the spring and everything, just very simple. 4 screws, make sure you put it back the same way. Yeah, I've got some pliers, some tool marks on this thing now, but not on the pivoting ends. It pivots there at those 2 points, so plier marks on this part don't much matter. So it needed one full turn. I'll show you this. One new thread is showing there at the base. It's shiny right after the green thread lock, because yes, it's glued in place with thread lock. Fantastic. And I can't really come up with another explanation. This was set short at the factory, because I don't possibly foresee how in normal operation the fixed distance between the pivot point there, the fulcrum point here, and this point here would change, this horizontal distance. I just can't get it how it could possibly change due to wear. Just baffles the mind. So now it locks. Next up is something with this power, and I noticed that one of the wires, okay, how do I do this with one hand? I guess I just put it here. One of the wires is really loose, so maybe like this one, that's there. So that's not a normal fit, that's nothing. Alright, so maybe a wire is loose somewhere inside this thing. I'll investigate. And it still has the loose wheel somewhere in there doing something, but so that's gonna be another story. Let me show you the electrical connections on the bottom end here of the unit while everything is open. The transformer coil is just clamped up there, so I can work with my hands here without the coil sliding everywhere, because I do not want to disconnect it. It's neatly crimped in here, and also there is it's crimped in here, and there is this plastic heat shrunk over it or around it, so I don't want to take it apart. So connections on the socket here look like this. This one here at the top, that's the symbol for ground, so the green wire goes in here. North American socket, North American color coding. N stands for neutral, that goes there. L is live. There is no pin here on the live. The pin here from the other side, there, that pin, you can see this metal plate is being extended down there, and from that point to that point it's being connected with a fuse. So the pickup point for the hot is here. Let me just show you. There's the little fuse here. It comes out with this screwdriver, and then this little drawer comes out like so. There, those are the fuse spring brackets, and that hold the ends of the fuse. So there, and there's a spare fuse on this one, so everything goes back together like so. And alright, green wire was ground, so it goes there. And this was the live, and I'll put it on it in a sec. This was neutral. This double combo thing was neutral, it just goes there, and so power comes in through this red one and no, I mean the power is picked up through the fuse, through this red one, and it's going to the transformer coil. Transformer has its own neutral that just connects here, and the rest of the juice is going through the red to the rest of the circuit board everywhere that's mounted here. The circuit board has its own male and female sockets and connectors. You can see they're numbered. Just match them: 3 to 3, 2 to 2, 1 to 1. If you wash away those ink dots from the white plastic with some solvent, that's tragic. You're gonna have to deal with it. And the rest of the wires just exit there through the rubber grommet, through that barrel hinge there at the bottom. And I removed already the rest of the stuff here, and I just for clarity, so you can see the electrical stuff here. So that's that. Through some crimping on, just with a pair of pliers, some crimping on some of these sockets, that solved my problem, which was the unit wasn't powering and wasn't running. Yeah, it's all fixed. It was just some loose wires, seriously. Alright, I'll put it back together. My work is done here. On assembly of this rod here, this rod there that's kind of pivoting a little bit, I found that this plate is a little bent there. You can see it. Just wait for the camera to focus. And there we go. You can see that it's bent out straight. So I'm gonna straighten it. That might be the result of, I don't know, it might be that it contributed to the rod not locking into the other part there. So I'm just gonna straighten it just for good measure. So that's just a small note there. Otherwise everything was very greasy with this yellow stuff, and it was dropping out left, right and center, so I cleaned up everything here, and I have some spare grease that I can apply to surfaces that do need to be greased, such as underneath this sliding rod there, that point there where you see that yellow grease, and you can see that most amount of wear there. So that's where grease should be, not hanging off in dabs between the spring coils. But that's just my assembly note on the North American quality here. I've lubricated everything where lubricant should be, or one point there under the springs, where it contacts the casing, the underside of this rod, where it contacts the other part with which it interlocks, the tabs sticking up on the interlocking part where it contacts those horizontal tabs on this push rod there. So it's lubricant is where it matters, not just everywhere, except where it should be. So the entire length of this rod needs to be lubricated as well, because of the friction there, the entire length of it is being used. So that's how this looks like. We'll put the transformer back, and we're in business with this. This coil transformer mounts fairly easily. All it's got is one piece of, I don't know, some kind of rubbery disc that goes down there. It's got a screw and a push plate on it. So it was, let me see, it was in this general direction. Just need to center the stuff, and that's basically all there is to it. Just have to center it there. That's basically it. Yeah, and I'm just There, that's torque is set for it. So we'll just put the after connecting this one once again, we'll just put the cover on it and put these four screws in that use the same wrench as the transformers. There, it's I don't know, let's see, 5mm hex key, 5mm Allen key. There, it's a hexagon thing. Alrighty. When you mount the screws down there, or the screws that hold this socket, you make sure that you don't over tighten them. This is aluminum housing and these are steel screws, and between the two of them the aluminum will lose every time. So if you over tighten something, the aluminum will get damaged. Good luck helicoiling and repairing the aluminum housing once these steel screws are overturned or over tightened or turned the wrong direction. So just go careful, pay attention. There, that's about how this one was. There. Same for this base plate. These screws are going into the aluminum case, so just be careful with it. So the unit works exactly as it should, locks in place quietly and stays so. There, flawless. Another source of electrical grief was the power cord. I went downstairs and found this power cord here, which is a power cord that fits with quite a bit of friction when it's either attached or detached. So that's the one I'm using now. The original power cord was like so. There, it's a 2-finger power cord. It's way too loose and it's unreliable. Okay, it is loose because it's slightly undersized. If we look at the actual country of origin on this one, just give me a sec. There, you can see that it is there, just wait, there we go. You can see I cannot really pronounce the stuff that says on it, but you can certainly give it a try on your own. So because it's made in China and it's supposedly compliant with CSA standards, no, it's not. It's slightly undersized. There's the fire rating, 60-degree cord, 18 gauge, 3-conductor, whatever. No, this one is slightly undersized, and the male socket end is really loosey and whatever, so it doesn't really provide a good electrical connection. That's why power is cut to it. Whereas the other one that I found downstairs, it comes with different lettering. The letters are printed on it in white ink. Just give me a sec here. The same 3-conductor 18 wire gauge, the same UL stamp, but it's a line tech cable. So I don't know where it was manufactured, but it doesn't say Chinese words on it. It's got the same numbers on it, whatever, fire rating. But bottom line, this one actually fits with some positive friction and a good electrical contact, as opposed to the Chinese made there. That's solid as it should be. And of course the unit runs like a dream. No matter what you do to the cord can be this way, cord can be that way. There, it's all sorted out. Alright, last thing to do is the wobbly thing inside this switch, that one little steel ball or whatever is rattling inside.